Hey, Miss Marion here. We are doing Unit 2, Lesson 4. So you need to go ahead and find your workbook. And so you need to go ahead and make sure you have your workbook. And then we're going to open up to certain pages in a second. Okay, so grab your workbook. So today, this is what we're going to be doing. So I can determine a sequence of transformations that maps one figure onto another. We're going to use mathematical modeling to show that two figures are congruent using a sequence of transformations. We're also going to be describing each transformation using correct math vocabulary. So when we're able to do that, that's when we know we'll be successful. And then we'll be successful when we can determine the correct order of transformations needed to map one figure onto another. So this is what we're covering for today. So vocabulary, so a sequence of transformations. It is two or more transformations that are performed in a specific order. So you know how lately we've been doing translation, rotation, reflection. Now we're going to do two of them, and we're going to do one right after another, okay? So first of all, I want you to kind of look at this picture, and I want you to think about what questions can you ask about this. So go ahead and thought process, think about it for a second. And so some questions we can ask are, okay, why would somebody build it this way? We can also look at different pieces of here. Notice how like this rooftop is the same as this rooftop. So I kind of wonder, are they the same? Notice how we have all these different colors kind of going on, right? And then notice how there's a lot of windows that are exactly the same. And then there's some of them that are not. So there's a lot of different things kind of going along with this picture. And so we're going to kind of talk about that today and how it kind of relates with the transformations. That's everything that we've been doing. And it's something that changes a picture as transformation. Okay. So we're going to be using this idea. All right. So we're going to look at this picture here. So as a landscape artist has designed a new patio for a client. And the client wants to verify that the first table here is the same as the second table here. How can an architect show that two tables are the same size and same shape? So think about it for a second. How can that architect can do that? So looking at these, can I take this table and can I do something to it to make it this one up here? So can I like take my trace paper and trace it and put it up here and see if they're the same? The answer is yes. So that's kind of what we are actually talking about today. So we want to see if they are congruent. So remember, congruent is same size, same shape. That is what we're looking for. And we're going to kind of do that together with that, okay? So what transformations could we use to show that? So remember, a transformation is a translation or a slide. It is a reflection or a flip. And it's also rotation, a turn. So which combination, or can we just do it by one? Which one will actually make so that this table here is the same as this table up here? That's what we're looking for right now, okay? So I'm looking at it as, okay, I could probably eventually slide it this way and then slide it up and then probably turn it also. Or I could probably turn it and slide it down. So there's different things that I can actually do. So I can slide it, and then like turn, right? So these are things that we can actually do to make it so that the two tables, that they are the same or they are congruent, same size, same shape. All right, so here's kind of my answer that goes along with it. And then how does the orientation of the first table need to be changed to match the orientation of the second? So kind of if I took this table and I just slid it over and slid it up, notice how it's not going to match. Well, actually, these two will match, right? But to make it so it looks exactly how it was before, what do we need to go ahead and do? And then are there any other ways to rotate the first table so that it can match the orientation of the second table? Do we always have to translate it first and then rotate it, or can I rotate it first and then translate it? So that's kind of what we're looking at as far as these pictures. So let's go ahead and let's open up our workbook to page 72. And on page 72, we can actually look at this and kind of see, okay, I want to take this picture and make it look like this. So the question is, could I rotate it first and then translate it? Or could I translate it first and then rotate it? Are these two picnic tables or tables, are they congruent? So the answer is yes. These are congruent because notice how it has two tables at the end and then three on either side, two tables on the end, three on the other side. So when we do a sequence of transformation, we can actually see if something is congruent or they match up. You could actually take your trace paper, trace it, turn it, move it, and see that these two are actually the same. So a rotation of 90 degrees clockwise would turn the table from horizontal to vertical. And then the two figures are congruent if one can be mapped onto the other with a sequence of transformation. So an architect can use a series of transformation to show that the two tables are congruent. That's kind of what we've been talking about. And then these two figures are congruent if one can be mapped onto the other. So what it means by mapping is I can use a sequence of transformation to show that they are exactly the same when you move it along with it. And it's kind of like our patty paper that we've been using. I can move it and see like the patty paper is going to sit right on that picture. So the question is, and maybe you want to try this, and again, we're on page 72, is could the architect have first rotated and then translated the first table to the map to see if it's going to be the same? So I want you to grab a patty paper and I want you to try that. Can it be rotated, then translated to make it the same? So go ahead and answer that question and then come back to me. All right, so could the architect have first rotated and then translated? That answer is yes. So on page 72, let's write this down. Yes, rotating, then translating, would also map or remove it to make it sit on top of each other, it to the second table. All right, so the next question, what other transformations could the architect use to map the first table onto the second table? So grab your patty paper, kind of play with that and see what things we could do to make it happen. So go ahead and do that and then come back to me. So the question is, could we do a reflection? Could I reflect that and then rotate it? That answer is yes. So we can say we can reflect the table, then rotate it, then rotate the table. All right, so notice how there's many different ways we can actually go ahead and look at this kind of stuff to do it. Do we have to do one in order? On this one, we don't have to do a certain one in order, but sometimes other times it does. All right, so this is on page 76, so turn to page 76. And it says, an event planner has redesigned a table layout for an upcoming event. Her client is unsure if the tables are the same in this new design. Is table A congruent to table A prime? Think about it for a second, and then come back to me. So I'm going to say yes, they are congruent. We could translate the table, then rotate it. the table. Okay, and I would write this underneath number 1. Sorry, on page 76. All right, again on page 76, let's look at number 2. Is table B congruent or has the same measure as B prime? So go ahead and answer that and then come back to me. Now I'm going to say yes, we could reflect it like across this line, and then we could reflect it across this line. Kind of see, you can try it with your patty paper. So we're going to say 2, so yes, 2 reflections or we can also do a rotation too. Right? Just write down whatever you had. And then now we're going to look at number 3. So we're going to look at letter C. So this is number 3. Is C the same as C prime? Okay, go ahead and answer that question and then come back to me. So is C and C prime exactly the same? Take your patty paper, trace it, put it on there. Are they the same? No. Okay, why not? They are different sizes. So remember, congruent means same shape. So we have the same shape and same size. So this was a no because congruent, it was the size part. One is smaller than the other. All right, looking at number 4, after which transformations will an image and preimage be congruent? Think about it for a second. Which of the things that we've been doing, translation, rotation, reflection, will make it so it's the same on both sides or congruent? Same shape, same size. Think about it and then come back to me. All right, so first of all, translation. Does a translation make it the same? If we slide it, is it going to still be same shape, same size? Yes. What about a reflection? If I flip it over a line, is it still going to be the same? Absolutely. And then if we think about it, does a rotation also do that? Absolutely. So these are the ones that will make it congruent. Translation, rotation, reflection. So remember, translation is a slide. Reflection is a mirror. Rotation is a turn. All of these will still keep it the same size, same shape, or congruent. All right, so this is our lesson for today. You do have homework in Canvas, which is derivative. Make sure you get your homework done. Make sure you get other stuff done too. And then also make sure you get your starter done, which is also in Canvas. So thanks, guys. Have a good day. Bye.